sucker, okay? Okay, so similar to perpendicular bisectors, since a triangle has 3 angles, it also has 3 angle bisectors. The angle bisectors of a triangle are concurrent. That means that they kind of meet at one spot. And the point of concurrency is called the incenter. Okay, so remember, look at this. This is triangle. We'll go with A, B, C, right? Now, this line here is an angle bisector. Cuts this angle A in half. This line here is an angle bisector here, which cuts this angle B in half. This line here is an angle bisector, cuts these in half, right? So the angle bisectors of a triangle intersect at a point called the incenter. So all these angle bisectors, AP, BP, and CP, all intersect at this place called the incenter. That's this spot right here. Now, the incenter now gives you some cool idea or cool information. If you know it's the incenter, then it's equal distance from the sides of the triangle. So the distance from here to the side, perpendicular again, is equal to this distance here, and also equal to this distance here. So that one right now is the incenter, gives you equal distance to the sides of the triangle. Unlike the other one that we did the other day. Oh, not that one. I'll just leave that one off. When it came to the circumcenter, it talked about having equal distance to the vertices. Okay, if it was the circumcenter. It's incenter here now, equal distance to the sides of the triangle. Okay, so let's go ahead and write this down, guys. Incenter. Draw the picture of it. Please make sure you know we're talking about the angle bisectors. Write that down. So if P is the incenter of triangle ABC, then PD, you see, PD, PE, and PF are all equal distance. And that's pretty cool, pretty neat idea, pretty cool feature that we will use today. Brianna, Caesar, we will use that one today in our Alex assignment. Okay, again, we will use that today with our assignment today, okay? Cut it down, see what you get. So find each measure if J is the incenter. Now, I'm just going to jump over here real quick. Find J. J is the incenter. You need to remember, on the incenter, this distance, and this distance all happen to be the same. So you got to kind of just, from the very beginning, realize that. Okay, okay. The incenter means it's equal distance to the sides of the triangle, okay? So let's look at the information they gave us here. If I know that this one here is equal to this one here, which is equal to this one here, all right, let me see. What are they trying to ask me? They're trying to say, hey, find JF. Where's JF? J to F. Shoot, I don't know anything about this one here. I know, okay, 15 is going to be this side length here. Or no. Oh, no, 15 is this side length. Okay, 15 is here. All right, I get that. Oh, man, I don't know that. You know what? I'm going to jump around. You know what? Look at this triangle here. Do you see something here? Do you see something here? Not so much. What I see here is a right triangle. Do you see it? You see that right here? This is a 12 down here. There's my 15 up here. Okay, now I'm going to tell you this much. You see this part right here? Which is this part right here? Whoa, isn't that the center, incenter distance to the side? So isn't it also that side there? So if I can use my a squared plus b squared equals c squared in this triangle and find out what this missing side is, then if I find it here, I also know it here then. Hey, pretty cool, right? So let's look at that and let's do that real quick. Oh, remember, this is your A, B, and C. C happens to be the one that's across the hypotenuse. C happens to be the longest side. Okay, C is the one across the right angle. So these are A and B, and you can interchange them and put this as A and that as B. But either way, let's just work with that right there. I'll go with A if you don't mind. I'll go with A squared plus 12 squared equals to 15 squared. Ava, your camera's on, Ava. Freaking me out. See, I get distracted. That's why you don't turn on your cameras. You're fine. You can turn it on if you want, but it just freaked me out. I was like, what's going on? So we'll come out here with A squared plus 144 is equal to 225. Subtract 144. Subtract 144. Cancels out here. We're going to go with A squared is equal to 81. So then we're kind of stuckish right there. But if I got the square root of both sides, then I get A is equal to 9-ish. Okay. So regarding that, I figured out this one to be 9, which is this one, right? 9. Well, then guess what this one has to be? 9 also. Okay, so look at that real quick. They did the same stuff we did. Slash, they got 9. Now, it's true. It could be plus or minus 9. We've never really talked about that, but I'll get you a lesson on that one later on. That one now, it says since it's a distance, it has to be positive, okay? Moving on. We're good on that one, guys. What do y'all think? Anybody have any questions there? Okay, let's move it on. Now, let's find angle JAC. If you look at JAC, okay, so we're looking for angle JAC. I'm going to go up, and I'm going to work it out, and then we're going to look at what the book did, okay? Look at this. They're looking for J. Let me change it to right. J to A to C. So I'm going to just kind of keep it small. They're looking for this angle here. They're looking for that angle. Okay. Now, when I look at that angle here, I'm looking at there's a whole bunch of triangles. But I'm going to step back and look at the big triangle. You see that? Okay, so that's part of the big triangle. That's also part of that small angle. I don't know anything about this small triangle here. But I do know stuff about the big triangle. And I know something about all triangles if you think about it. When I add up all the three angles of a triangle, don't they all add up to what? 180? Since they all add up to 180, well, I don't know anything about this angle, but I do know stuff about these angles. And since this is an incenter, this angle is equal to this angle. And this angle here is equal to this angle here. And then this part right here is equal to this part here. So these two are equal, these two are equal, these two are equal. Well, if you kind of look at this, I can figure out what this measure is, I can figure out this measure, and then when I have those two measures together, subtract it from 180, it'll give me this whole measure of this two together, and then just get half of it, if that makes sense. So let me approach this real quick. So I'm going to say, you know what, and this corner over here, I already have 32 times 2, because I have two angles there. This one is cut in half. Since that's 32, this is also 32. And if I go this side over here, well, I have 34, but I have two of those, because this is 34 and that's 34. And when I add it up, look at this side over here. If you think about this side over here, I have what I have. Let me go with that angle. JAC. They want what? JAC, right? I have JAC, and I already have two of those. And when I add them all up, it gives me 180. So I'm just going to approach it like that and do the math there like that. This one here gives me 64, plus this one gives me 68, plus, if you don't mind, I'm going to throw the 2 in the front. 2 of angle JAC will equal to 180. Guys, I'm sorry, my handwriting is so bad, I don't know what's going on with my pen either. So I'll add these two up. That gives me 120, 132. Plus 2 angles of JAC, that's equal to 180. So I'm going to subtract that 132 from both sides. Subtract 132 from both sides. And I'll get 2 angles of JAC is equal to 50, 48. Okay, so in this situation, I have 2 of these to equal to 48. But I don't want 2 of them. I just want that one side. I don't care about this one. I just want the one they're asking about me. Yeah, see, good job. See, they already got it. So I'm going to divide by 2. I'm going to divide by 2 and say angle JAC is equal to 24. It wasn't too hard. Just, first time we see that, make sure you know incenter angle bisector. Okay. Let me see what else. Let me see what the book got. Please make sure we got it right. Well, if you look at it, this did the same thing. They had 2 34s, right? They had 2 32s. They added them up, got 132. Subtracted 132 from that 180, got 48. Remember, FAE happened to be the what? The big side, which is double of those. So instead of having that double, we just came out here and got JAC, which happens to be half of them, and we got 24. Not too bad. I think that's pretty cool. I think it was a pretty cool little keep track of everything practice problem. Yes, squiggly line. Here we go, ready? Let's go ahead and try number, where are we at? 4A and 4B. Okay. Well, incenter, guys. Incenter is going to be right here where we have angle bisectors. So regarding that one, this is also 27. Make sure you know that this is also 31. I know this distance here is equal to this distance here, which is equal to this distance here. Okay, so that's the incenter, and it gives me that idea. So let's come out here. Where's PK? PK is right here to here. All right. I don't know enough about this triangle. I do know it's a right angle here. I don't have any information about this side, or anything like that. But if I look over here, there's this triangle here. And if I look at that triangle, I have a right triangle, and it looks like this. And that gives me what? A squared, B squared, and then C squared. If I look at this one, this is 20 up here. This would be 12 down here. So when I come out here, if I find out oh my gosh. Right now this one over here is A, and it's equal to 12. When I find this side over here, this unknown side right here, I'm sorry guys, my pen is just all messed up. That's that side. It'll give me that side. All right. So if I look at that one, okay, let me see what's going on. We'll do the A squared plus B squared equals C squared, right? So I'm going to go with 12 squared plus B squared equals to 20 squared. This one gives me 144 plus B squared is equal to 400. I'm going to subtract 144 from both sides. This cancels out. I'm going to go with B squared is equal to 256. So 256 is B squared. I don't want to know what B squared is. I want to know what B is. So I'll get that B squared, and I'm going to go ahead and go 256 and get the square root of both sides. You put it like that, yes. And they give me a B is equal to 16. Okay, so I found out this one is 16 right here. So guess what? That's also 16 right there. And they want us to find PK, right? And PK is right here, slash equal to 16. Okay, Jenna. Why I set it up like this? Is that the part?
Yes, and why you put that 12 equals 45.
Okay, so that goes back again. I kind of drew it. You see this one right here? So I kind of drew it facing the same direction. Let me just redo it again. I'll draw a little bigger. My pen is, I don't know guys, it's going to the other screen. It never goes to the other screen, and now it is. So it's kind of like stretched out. I don't know, it's not even cool. So this side right here is a right angle on this side. But I'm using this side over here, so that is my right angle here, right here. Now when it comes to that one, I have a right triangle. This side length down here is this side length down here, which is 12. Across it, across this one is 20. Okay, so when I have that right there, I have a right triangle. You want to think of a squared plus b squared equals c squared. And C's are put it, it's a Pythagorean theorem. So when you have a right triangle, there's a side length, okay? There's a side length relationship. If you get the two smaller sides and square them, and add them up together, they're equal to the side length of the hypotenuse, so that third side length squared also. So what you need to remember is this, there's three sides, A, B, and C. C is always the biggest one. Okay, so the big one is across the right angle. So that's my 20. So when I came up here, I would set up the 20 here as my C. C always has to be the one across the right angle slash it's your longest side. So when I set it up over here, I set it up right here across as my C. Next thing I came out here and did, well, if you look at these two, it doesn't matter whatever you do with these two. You could have it as b squared plus a squared, because either way you're going to square it and then add them together. So it doesn't matter if you square these in that order and then add it to the first one squared. So when it comes to these other two sides, you really don't need a specific order. So this is me, Jenna, and this is, I don't know why I always do this or whatever. Whatever I see first, I go as A, if that makes sense. And this one over here that I don't know, or the next one, is B. I really could set them up either way. So then this one I'll just set up over here as 12, because that was that bottom length right there, squared, and then plus that other leg, B, the unknown, and it just goes like that. So just help me out, Jenna. This C is the only one that really needs to be in its spot. Ooh, I forgot the square. These two over here, the A and B, you can switch them around. What do you mean, sir? Well, if I put the 12 over here, you see how this basically says the same thing? I'm either going to find it as an A, which is an unknown, or B as an unknown, but either way they'll wind up being the same process. And remember, a variable is just a variable. They can change it to whatever they want. Okay, did I help you out there? Yes? Awesome. Okay, so all of this, guys, is 4A. Let's try 4B now. Again, I'm sorry for my handwriting being extra messy. I know it's messy, but it seems to be extra messy because I'm being serious, just stretching out my movements. Okay, so 4B, let's look at 4B. 4B is asking us to find angle LZP. LZP. So it wants us to find out what this angle is there. Okay, that comes to, I guess, our second example right above us. So we don't know what this one is, but we know that this line here bisects it, right? And you have these two angles, right? Now these two angles are 1/3, you can say, of the whole big triangle. And 27 here, this is an angle bisector, so this is also 27 up here. This is 31 for this part, so this one's also 31. Now I'm going to go back to the idea. If I add this plus this, angle is right. If I add all those angles up, they equal to 180. So I'm just going to approach it like that. I'm going to go with, let me see. If you don't mind, I'm actually going to put this one first, just because I see it first. Two of these angles, right? Angle LZP. Two angle LZPs plus two of these 27s. Two of these 27s plus two of these 31s. It all equals to 180. Okay? So I'm just going to go with that and finish my math up really fast. This will be 54. I'm going to scoot it over a little bit. Plus over here, 62 is equal to 180. Now when it comes to this part, I still have to add up the two angle LZPs. All right. Now I'll add these two up right here. That's a 6, and then an 11 equals to 180 plus 2 angle Lcp's. Let's subtract 116 from both sides. And we go 2 angles of Lcp's are equal to 180 minus that one is 64. Okay, so now I have 2 of these angles, but I don't want 2 of them. I want only one angle, so I'm going to divide by 2. Divide by 2, and we'll go angle Lcp is equal to 32. Wow, my hand is cramping. What do y'all think about that one? So that one, angle Lcp is 32, and we'll go with degrees. Going once, going twice, maybe más o menos.